In the previous video, we solved exponential equations by rewriting those exponential equations in logarithmic form. Now, we can also use the exponent property to solve logarithmic equations. And often what we're going to want to do, given a logarithmic equation, is to rewrite it in exponential form. And just as in solving any equation, you must remember the goal, which is to get the variable by itself. Okay, so here we have log of x over 42 equals 1.71. So the first thing we're going to want to do is to rewrite this equation in exponential form. So we need to know, first of all, what is the base of these logarithms, right? LOG without a subscript means the base is 10, right? The base 10 is understood. Okay, so 10 is the base. Where is the exponent? Well, that's the answer on the other side. Okay, so then we have 10 to the 1.71 power equals x over 42. Well, now it's easy to solve for x. We just compute 10 to the 1.71 and multiply by 42. And the answer is approximately 2,154. Okay, next example, we have 1.4 times the log of x over 38 equals negative 4.738. Now in this case, the logarithm is multiplied by a factor. And so we're going to want to get rid of that factor first. So the first thing to do before we rewrite the equation is to divide by 1.4. Okay, then we're going to rewrite in exponential form. Okay, again, the base of the logarithms is 10, so that means we're going to need 10 raised to this power, negative 3.384, equals x over 38. And it's a simple matter on our calculator to raise 10 to the negative 3.384 power, and then multiply by 38, and the answer is approximately 0.0157. Now let's look at some examples involving natural logarithms. The examples we looked at so far did not involve the number e, but occasionally you will run into problems where the number e is involved, and if that's the case, then you should use natural logarithms. So for example, we have e to the 3.8 equals x. This is easy. All we have to do is raise e to the 3.8 power and get our answer. Now we have e to the x equals 342. This is easily solved simply by taking natural logarithms of each side. On the other hand, if we're given the natural log of an expression involving a variable, then we're going to want to raise e to the power given by the logarithm. So we raise e to the 7.304 power, and we get our answer, approximately 1,486. Okay, we may also need to use the exponent property of logarithms in conjunction with the number e. So for example, we have e to the x plus 5 power equals 3,409. We take logarithms, and we find x plus 5 is equal to natural log 3409, and then subtract 5 to get our answer. That was easy. All right, now we have e to the 0.237x equals 54.8. Take natural logarithms. And we find natural log of 54.8 is approximately 4.004. And then divide by 0.237 to get our answer. Do one more example. Here it is, 6.71 times e to the negative 1.74x equals 2.08. Now again, we have this factor out in front, this multiplier. So the first step will be to divide by that factor, 6.71 on each side. And that gives us e to the negative 1.74x, approximately 0.310. Okay, and now take natural logarithms. And then finally divide by negative 1.74 to get our solution. X equals approximately 0.673.